So you'll get my voice, but I'm not going to put anything on the screen. It's all going to be on the chalkboard. And also there'll be no delay. So the way this is supposed to work, and I think it is how it's working, is there's an 8-day. Oh my goodness, it's the GSIs chattering away at the top of the room. How horrendous. The way this is supposed to work is that there's usually an 8-day delay on the posting of the screencast so that you don't have them until after you've turned in the problem set for each week. And then, as we approach exam week, the Thursday from last week should be posted with a 6-day delay, so it should be available tomorrow morning along with the Tuesday. And then this review will be posted immediately with no delay. So I think that means it'll actually be available like right after the exam or later today. I mean, right after the period today or tomorrow morning. I can't remember, but soon, right away. Okay, I'm going to cancel my office hours on Thursday because I've got to take my scooter to the shop. Does anybody have any logistical questions? I'm going to talk about the contents of the exam and the format in a little bit. So does anyone have any questions about anything that isn't actually the exam itself? Okay. So now I'm going to switch that off. The time will come when I'm capable of writing up a nice handout for an exam review and writing an exam in the same week, but I'm not able to do that yet. So I'm just going to refer to the review outline that you've all got hopefully in your hands. The first thing is, I had one student send me an email saying, could you please cover the following? And what I want to say something, I don't know who that student is, but I'm going to say something specifically to that student, which is if I don't answer your question during the review, because I may not get to it, please come and talk to me after the session and I will explain it to you. Okay, so first of all, with respect to the format of the exam, there will be 3 short answers of which you will choose 2. Now, when I say short answer, they're not that short. They're not sort of like identify this thing and write down a 3-word name. Each of the short answer questions has got its own page for you to answer. So most of a page is blank. You don't have to fill that page. In fact, the more compact your answer is, the better, as long as it's complete. Okay, so you want to give a complete answer. So really, it should be medium answer, not short answer. 2 out of 3, 10 points each out of 100. And I'll say this again on Thursday, but I want to emphasize it now. Don't spend too much time on the short answer questions, at least the first time through the exam. You can really waste a lot of your time there at the beginning of the exam, and students in this format of exam routinely spend much too much time on short answer questions. So if necessary, read them, put down a couple of sentences, come back later. Okay. Then there will be 2 multi-part problem-solving questions that will be similar to what you've seen on the problem sets, and those are all of those 2 problems are required. There's no options on that. There's going to be 100 points total on the test. 20 of them I've already said are from the short answer. 20 of them will be from parts of the problem-solving problems that are quote-unquote harder in square brackets. Now, it's very difficult to judge how hard a question is actually going to be when you write it. So on the problem sets, I think some of the harder problems have been insanely hard, and some of them actually wound up being turned out to be an easy way to solve them. But I'm trying to make them a bit harder without making them sort of insane. What I want to suggest is, I said when I was going over the syllabus at the beginning of the semester, my intention is that you should be able to do fine in this class by simply understanding the core material I present in lecture, which you then are asked to practice on problem sets, which will then be duplicated roughly on exams, like slightly different settings, same basic math, same basic concepts. You should be able to do fine. It's unlikely, mastering that basic material, that you will get a really stellar grade. Unlikely you'll get an A+, maybe not even an A, but you should be able to do what I'm going to call fine. Now, people have different, that's actually mine. Sorry, I realized that was a little unclear. So don't worry too much about the 20 points that are labeled harder. My hope is that it should be no problem for you to finish the 80 points that aren't labeled harder, no problem in the time allowed. Some of you may find it challenging to finish the harder parts as well in the time allowed, but don't worry about that too much. It is my impression from talking to your GSIs that for the most part you guys are doing fine on the problem sets, so I anticipate that you will do fine on the exam as well. Don't worry too much. This is figuring out exactly how much to worry is an important skill in life. You want to worry a bit, but not too much. It's bad for your health. Okay, the final thing I want to say about the exam itself is that a lot of the questions in the problem-solving part, almost all of them, will ask for sort of what is the intuition for your answer. So what's the economic or psychological intuition? And I don't think I've used that term, intuition, very much. But on the problem sets, there's been lots of questions where you're asked to sort of explain the psychology behind this. Why does this happen? So let me just talk about what I mean by that a little bit, in case it hasn't become clear. And probably the best way to get a sense of what I mean by it is to just read the solutions to the problem sets. I tend to bloviate a little bit, and so some of my answers to what's the psychology behind this may be a bit longer than is strictly necessary, but it should give you the style that I'm looking for. So let me just give you a very simple rubric for thinking about this. Okay, what we're looking at in psychology and economics is a kind of dynamic relationship between psychology and economics that is mediated by math. Okay, this math and economics, right, is sort of standard economics. This psychology and math, well, math a little bit is psychology by itself. People are increasingly using math to model psychology, and what we're doing is we're linking the two, but making sure to keep the math link. If I ask you for psychological intuition, I'm asking you to comment on how. So the typical, there's 3 ways you can answer a question like what's going on or explain why this happens. One is just to look at the model and say, well, in the math, this happens here because the slope is higher here than it is here. Or there's a kink, so therefore the marginal utility goes up, blah, blah, blah. That's just math, okay? By and large, I want you to err on the side of going from math towards economics or from math towards psychology in some interesting way, okay? It's over and over again, I think the biggest mistake that we make in undergraduate economic education is that we leave students with the impression that the math is the content, okay? And the math is absolutely meaningless outside of an undergraduate economic classroom. Okay? And when you graduate and have turned in your last problem set and your last exam, in all likelihood, you will have used mathematics to explain economic concepts for most of you for the last time in your life. And the rest of your life, you'll just be trying to explain to people what's actually true about economics and not how to write it down mathematically. So the things I want you to be able to do on the exam over and over again are about seeing how psychological concepts, and I'll touch on sort of the list of what we've looked at so far, are embedded in the math, and then using the way that the psychology is captured in the math to explain the economic phenomenon that you're looking at. Okay, so economics is about people's behavior. What choices do they make? They take this gamble, but they don't take that one. They work until a certain point and then they stop. Okay, if they're behind, their risk choices change. They have a higher or lower certainty equivalent, etc. That's economics. Psychology is, oh, well, they care less once they're in the domain of gains because they're no longer suffering a loss relative to their reference point, so that just doesn't feel as bad to them. Right? That's psychology. It's all hand wavy, right? So explain the intuition behind your answer, ... means demonstrate that you understand what psychological concepts are captured in the math and how those psychological concepts are driving the economic behavior that you've just solved for in the problem. But typically, I'm going to want you to keep your eye on the psychology. Okay? It's not enough to just sort of explain, oh, well, this thing is convex, so therefore, Why is it convex? What does that mean? And not just why is it convex, but why does the reason it's convex, the psychological reason that this thing is convex, drive the economic result? Well, when she's in the domain of losses, more losses don't feel as bad as the first bit of losses because of diminishing sensitivity, which is captured in the convexity in the domain of losses, right? Think in those terms. That's how I want you to answer those kinds of questions. Rachel?
So in a way, you can think of it as, when you're explaining the economic aspect of it, that's kind of explaining the choices they make, and then psych aspect as why they make those choices?
Yes. Did everyone hear what Rachel said? So the economics would be explaining the choices that they make, and then the psychology would be why. Roughly, yes. Now, you could say, taxi drivers stop working because they reach their income target. That's a purely economic explanation. And you could say, well, I'm done explaining. If I ask you for a psychological explanation, I want you to explain to me what that income target is doing psychologically. It's a reference point beyond which their marginal utility for income that day goes down, so they don't care as much about earning more money than that. That's why they stop when they reach their income target. So answering the question why, right, in most of economics, it's just sort of this. Well, they reach their income target, and marginal utility goes down. Which is, and I want you to understand that, but I want you to understand why their marginal utility goes down when they reach their reference point. And why it might then continue to go down if I'm also modeling diminishing sensitivity. Okay. So that's about what's going to be on the exam. Okay, the next thing on this outline, I'm going to tip my hand and reveal to you if the style seems a little odd. What I did was, I sat down and I said, okay, what do I need to tell these students? And I wrote it as if I was writing to myself. And then I thought, okay, now I need to rewrite it as if I was actually writing to the students. And I thought, I just don't have time for that, so I'll just cut and paste it. So in places, it may look a little bit like sort of talking to myself. So over and over again, we're using the concept of indifference to solve problems. And we started out at the very beginning, actually looking at results from mug and candy bar experiments and drawing out indifference curves, right? Now, how did we draw out those indifference curves? We took binary choices, sell a mug, don't sell a mug, okay? And we figured out the price, the selling price, that would make the person indifferent between selling the mug or not selling the mug, okay? Now, I want to clarify, in case it hasn't really sunk home, that we are using utility maximization to develop these indifference curves and to figure out these solutions to what's the price that would make the person indifferent, what's the G that would make the person indifferent between taking the gamble and not taking the gamble. Okay? So I want you to really see how that process is really a process of utility maximization. So I'm going to work through a problem that was supposed to be on problem set 3 that wasn't, and you'll see I've added it into the solutions because it'll help you understand the house money effect and particularly the house money effect, but also the break-even effect. So I'm going to call this problem set 3 problem 1B prime. It was originally C, and my computer somehow just decided not to print it, and I don't know why. I mean, I do know why. It's because I did something wrong, but I don't know what I did wrong. And what the problem was supposed to ask you was, before you did anything about having won or having lost, it was supposed to say, suppose this is Lydia's first round of blackjack for the day and she's not won or lost any money yet. What is the G for which Lydia would be indifferent between taking a 50-50 win G or lose 5 gamble? Okay? So what we're doing, always, is we're saying, what is the number of utils, given the utility function that we've come up with, what is the number of utils that she will get if she chooses thing A, and what is the number of utils she will get if she chooses thing B? And then we find ourselves in a situation where the number of utils if she chooses thing B is a function of something that we can change, like a selling price or G, the size of the upside of the gamble, that kind of thing. And then you're just going to adjust G until those utilities are the same. But I want you to sort of see how that's actually harnessing the power of utility maximization, because that's going to help you apply the concept in lots of different places. So her options here are, she cannot take the gamble, which means that she will stay with her current level of wealth, which is currently equal to her reference point, and we're going to normalize her reference point to 0. So not taking the gamble is going to give her a monetary payoff of 0. Okay? So we want to know what's the utility of taking the gamble 0 with probability 1. Okay? And then we want to find the place where that is equal to the utility of taking the gamble minus 5 with probability 0.5 plus G with probability 0.5. Yeah? Myself, I've already told you that my IQ goes down by 10 or 20 points when I'm standing in front of a group of people. It goes down even further when I'm taking an exam. One of my biggest rules for taking exams or doing anything where the pressure is on is don't skip steps, because I do extraordinarily moronic things when I'm under pressure. And I'll skip steps and say, oh, I can figure that out. I can go straight to the utility function itself, and then I'll leave out a minus sign. And I'll spend 15 minutes trying to figure out why I can't get the right solution because I've left out a minus sign somewhere by skipping steps. So I encourage you to not skip steps. It's called going slow to go fast. So write down, what is the utility function? The utility function is 1/2 v of m minus r plus 1/2 v of m prime minus r, right? Where m is the payoff in one state of the world and m prime is the payoff in the other state of the world, where v of x is equal to, it's just the usual one, right? No, it's this, where did I write it? It's log of x plus 1 for x greater than 0, and it's negative 2 log of negative x plus 1 for x less than 0. What I want to most strongly encourage you here is forget about this specific utility function, forget about this specific gamble, forget about even the setup of choosing between gambles or certain amounts. Just think about the basic procedure that you want to go through. The first thing you've got to figure out is, what's R? And, happened to me when I was learning this stuff. I've watched people for 2 semesters in this class, happens to students as well. We get completely wrapped around the axle trying to figure out what m minus r is. So we're like, wait a minute, so what is her consumption? I understand why, but that's a loss. She should be going down from her reference point. That's like the scene from Princess Bride where they go into the swamp with the big wombats. Just don't go there. Just write down what R is. It's not, write it down and then just don't change it. It's 0, right? In this part of the problem, R equals 0. We're harnessing the stability of math. Math is like putting ladders over thin ice. You won't fall through, okay? Now, then we can go and we can say, okay, so once I know what R is, then all I need to do is to figure out in each of these situations what M is. Well, here, there's only one outcome, right? That's M right there. That's what that thing's doing there. This is the utility of having a certain outcome in dollars, regardless of your reference point. Okay? We'll get to the reference point. We've got the reference point. Don't worry about the reference point. It's just 0. So write down, okay, so that's the utility for not taking the gamble is, okay, so, sorry, that shouldn't have been, that should have just been like a p and a p prime, right, because those could change. So what it is, it's like, okay, it's v of n minus r. Well, I just said n was 0, and r is 0, so it's v of 0 minus 0. Now, here's what tends to happen psychologically to me, is I get to this point and I think to myself, if anybody else could see me taking these baby steps, they would think that I was a moron. Surely I can skip these steps. Resist. Don't do it. Just do the moron thing. So that's not taking a gamble. Then take the gamble. What's the utility for taking the gamble? Well, it's this. Okay, so it's going to be, the probability is 0.5. Okay, so 0.5 times, what is this? The value of n minus r. What's n here? Oh, it's negative 5. Right? V of negative 5 minus r. I don't have to sit here and worry about, is she up, is she down, where's that one? Just plug in r. It's 0. Boom, you're done. Keep it simple. Do the rest, do the thinking later. Okay? And in this case, it's like, oh, it's g. She doesn't have any other money in her pocket yet, so it's just g minus r, which is 0. Sorry, there's supposed to be a v in there. Then what I like to do is I like to come along and say, but what v is depends upon whether I'm above or below my reference point, whether the thing in brackets is positive or negative, right? So then what I like to do is I like to come along and I say, negative 5 minus 0. That's negative. Okay, that tells you what part of the value function I'm supposed to be in. This thing, g, is g positive or negative? Well, I think g's got to be positive, right? Because the setup of the problem is, would she take a gamble where she gets this or gets that? And it doesn't, where she loses 5 or gains g. It's like, okay, so g's got to be positive. So that's got to be positive. That's straightforward. And then I can plug in, well, what is the actual value function? So this is going to be 0.5 times log of x plus 1. What was x? It was this thing in here. It's negative 5. I'm about to skip a step. Watch me do something wrong. Hang on a second. So x is negative 5. Log of negative 5 plus 1. Oh, wait a minute. Sorry, that's in the negative, so I'm supposed to be here. That was what you were going to say, Palace? Okay, I'll come back to you. So I'm here. X is negative 5. Negative 5 is 5. Plus 1 is 6. So it's negative 2 log 6. 5 times negative 2 log 6, right? And then this one's in the positive domain. Okay, so let me go over there and get that. X is g. G minus 0. G plus 1. So log 0.5 log of g plus 1. And then what am I doing? Oh, v of 0. That's just the log of 0 plus 1. Don't forget, go back to the actual value function. V of 0 plus 1, right? Which is 0. And just, boom, set them equal. So I'm trying to emphasize a number of points here. I'm trying to emphasize, start by figuring out the reference point, and then stop thinking about the reference point, just plug it into the math. Okay? Then figure out what m is in each of the different situations that you care about, and then plug that into the math, and stop thinking about what it means or where it is relative to the reference point or anything like that. Alice? You didn't know whether g was going to be more or less than 10. I'm going to get to that. Yeah, but we don't want to mess with most likely. Most likely is unfortunately not a mathematical concept. And I'm going to come back to that in 1 second. Yeah, which is a question of where you are relative to a piecewise function. I'm going to talk about that in a second. So to really lean on the math. The point of economics, the whole point of the methodology, is that you take a bunch of concepts and embed them in math, and then you can relax and just lean on the math, right? So you plugged all these things in. Then I want you to see, why am I setting these two things equal to each other? Because basically what I'm doing here, right, I've defined a utility function over gambles. And what this utility, the concept here is that this utility function over gambles, like any utility function you ever see in microeconomics, is designed to allow me to rank Lydia's choices. And then I'm going to make the assumption, which we never talk about, that she's going to choose the thing at the top of that ranking. That's all utility maximization means. This mathematical statement here is already a step ahead. It's built on the idea that if you give her a certain outcome, right, in this case 0 with probability 1, and then you give her a gamble, or if you give her 2 different gambles, she's going to choose the one that pops out a bigger utility number. So that's utility maximization. But it's a special case of utility maximization where there's only 2 choices. Normally when we think of utility maximization, we think, oh, look, she could have this much of good 2 or this much of good 1, and there's all these complicated choices in between, and she's going to pick the place where her marginal benefit is equal to her marginal cost. But that's where you're choosing over an infinite continuum of different possibilities, right? And you actually are going to do some calculus. This is a situation where we're only choosing between 2 options. Okay? Don't gamble, gamble. But the fundamental concept is the same, which is you're going to plug those options into a utility function, you're going to pick the one that's bigger. Then, we typically like to set problems up to say, rather than just asking which one is she going to pick, to say, how would we have to manipulate one of these choices in order to get her right to that break-even point? And that's where this equal sign is. So you may see questions on the exam that ask you similarly to find that break-even point, where utility maximization leaves her indifferent, okay? Or you may be actually given G, or given all of the details of the 2 different outcomes, gamble, gamble, don't gamble, and ask which one she'll choose. Actually, it's possible to be asked which one he'll choose. So that's how I want you to sort of get that what we're doing here when we set up these indifference conditions is very similar to what we do in cases where we find some first-order conditions for utility maximization, right? It's just setting up a condition in which she would be indifferent between, in this case, for example, moving this way along her budget constraint versus moving that way, in this case, between gambling or not gambling. And I'm going to answer Palace's question in a second, but let me ask if there's any questions about that. Okay. So Palace's question is, what do we do in a situation where, right, one of the things I pointed out to students who came to my office hours yesterday, when we, in standard 100A Hicksian utility theory, when we say we assume that people have convex indifference curves, convex preferences, that they like average bundles sort of in the middle here better than they like extremes, we draw this nice smooth curve, and we're implicitly assuming that this relationship between how you feel at x1 and how we feel at x2 is this nice smooth differentiable curve. Okay? If it's differentiable, that means we can take first order conditions and solve for utility maximization using Lagrangian optimization or even non-constrained calculus optimization. There's nothing in Hicksian utility theory that says that indifference curves can't be kinked. It says they can't cross, and if they are kinked, they're likely to cross. But it doesn't actually say they can't be kinked. That's convex, right? But the thing is that it's not differentiable.